Chapter 4, Lesson 6, Extension. The objective for the extension is to learn to evaluate expressions with square roots. Essential question: how do I simplify, add, and subtract square roots? For this lesson, you're going to want to have a list of the perfect squares handy, at least up through 12 times 12. Knowing your math facts can make this lesson a lot easier. We want to simplify square roots, but now we're looking at it from a perspective of we want to avoid decimals, we want to avoid making the numbers look messy. So we're going to keep square roots around. Some perfect squares can be factored more than one way. When simplifying, it is often easier to find the greatest perfect square factor before you start to simplify. So what the example is showing is that we can break apart the square root of a squared times b and do the square root of a squared and the square root of b separately. We know the square root of a squared is a, and the square root of b can be left in simplified form. So we want to simplify this. That doesn't mean take and find what the decimal is from your calculator. It means we want to break it down so we can find what this would be, still maybe containing a square root. First, look at 180 and figure out which perfect square you can divide it by. So 180 can be divided by 36, so it's the same as 36 times 5. Now we break this apart. We take the square root of 36 times the square root of 5. We know that the square root of 36 is a number 6, so we end up with 6 square roots of 5. This is simplified form. This avoids decimals and allows us to combine terms if we're able with the same square roots. Method B would be taking any perfect square you can think of. So we could do 9 times 20. We know the square root of 9 is 3, so we get 3 square roots of 20. However, this is not simplified because 20 can be broken down by another perfect square. So we need to continue working. We keep the 3 in front, and now we find the square root of 4 times 5. Separate those individually. We take 3 times the square root of 4 times the square root of 5. We know the square root of 4 is 2, so now we have 3 times 2 times the square root of 5. Multiply 3 times 2 to get 6 square roots of 5. That took a few additional steps because we didn't start with the greatest factor. Let's try another one, 245. So your first job is to figure out what perfect square divides evenly into that number. 49 is the greatest. So we would break that down to the square root of 49 times 5. Square root of 49 times the square root of 5 is equal to 7 square roots of 5. How might this be useful? If we want to simplify, we cannot subtract the numbers the way they are. Yes, we could use our calculators and we could get decimal answers, but this is another good way to practice. So the square root of 98, let's try to break that down first. 98 is the same as 49, which is a perfect square, times 2. We'll keep the minus 7 square roots of 2 at the end so we don't forget about it. Square root of 49 is 7, so the first part turns into 7 square roots of 2. Well, now we have 7 square roots of 2 minus 7 square roots of 2, which are the same, which equals 0. Let's try another one. 3 times the square root of 108 minus 2 times the square root of 3. 2 times the square root of 3 is simplified. 3 is not able to be broken down by any perfect squares. But we can break down 108. 108 divides into 36 times 3. So the square root of 36 is 6. So now we get 3 times 6 square roots of 3 minus 2 square roots of 3. Continue to follow order of operations and multiply 3 times 6. So 18 square roots of 3 minus 2 square roots of 3. It's like combining variables. If the square roots are the same value underneath, we can add and subtract the coefficients. So we can take 18 minus 2 to get 16 square roots of 3. If they were different square root values, we would not be able to do anything else. Make sure your notes are filled out completely. On the left-hand side, write questions that could be answered from the material in your notes, and review your notes and complete the summary before class.